If A is equal to 1, 2, 3 and B is 1, 4, 6, 9 and R is a relation from A to B defined by X is greater than Y, right? So what is the relation here? X is greater than Y, right? So the relation between X and Y is given and you need to find the range, right? What is the range of the relation? So now there are 3 elements in A and then 1, 4, 6, 9, 4 elements in B, and the relation between these two sets, right, A and B, is given here. Before finding the range, let me find the ordered pairs which satisfies this condition, right? So X is greater than Y. So here X belongs to the first set A and Y belongs to the second set B. So ordered pair will be XY, right? And this XY must satisfy this condition. So now here, so what is that? What are those pair of numbers which satisfies this condition? So if I take 1 here, right? So is there any number from the second set which is less than 1? No, we don't have any number in the second set which is less than 1. So you can't take 1. Now let's take 2. Okay. And this 1 here from the second set is less than 2. So the first ordered pair which satisfies this condition is 2, 1. All right. Next. Okay. Next, let me take 3. Again, we have 1. Right. So here X, this is our X. X is greater than Y. That is 1. 3 is greater than 1. So again, is there any ordered pair which satisfies this condition? No. Right. We don't have. And because see here, 1, 2 and 3, only 3 options are there, and here only 1 is the number which is less than these two. So 2, 1 and then 3, 1. This is the ordered pair which satisfies the given condition. But the question asked here is a range, and we all know the range is the second element from the ordered pair, right? So that is 1, right? So the range here is 1, and the correct answer is C. 1, 3, 2, 5 and 3, 3 are 3 elements of A cross B, and the total number of elements in A cross B is 6. Then the remaining elements of A cross B, right? So what is A cross B? A cross B is a Cartesian product, right? And 1, 3, 2, 5 and 3, 3 are the 3 elements of A cross B, right? Right? A cross B is equal to 1, 3, 2, 5 and 3, 3. Okay. And here the total number of elements in A cross B is equal to 6. So there are 1, 2, 3 and slots to be filled, right? So now how to find the remaining 3 elements? As you can see here, this first element 1, 2 and 3 belongs to the first set A. So you can write A is equal to 1, 2 and then 3. And the second set B, these 3, 5 and then 3 belongs to B. So 3 and 5, because when you write elements in a set, you don't repeat the same number. So here 1, 2, 3 and then 3, 5. As you can see here, the total number of elements in A cross B is 6, and we know number of elements in A cross B is equal to number of elements in A into number of elements in B. So here 3 into 2 is equal to 6. So what it confirms is there are total 3 numbers in, or 3 elements in set A and then 2 elements in set B. So now how to find the remaining elements? So now A cross B, 1 to 3 we have here, 1 to 5, okay, and then 2 to 3, and then 2 to 5 we have it here, 3 to 3 we have it here, 3 to 5. All right. So the remaining elements in A cross B are 1, 5, 2, 3 and then 3, 5. Okay. The smallest integer function f of x is equal to this. Okay. So here you need to check this smallest integer function is 1, 1, many 1, or both, or none of these, right? So before this, let me explain what is the smallest integer function. smallest integer function, and we have one more called greatest integer function. Okay, you have this greatest integer function in your textbook. So what is greatest integer function? If I write f of x is equal to greatest integer function of x, so here if I take f of 1.5, right, so this will become greatest integer function 1.5. so here the greatest integer function of 1.5 will be value of an integer or an integer less than greatest integer less than the given value, right? Greatest integer, let me write it here, greatest integer less than given value. So here 1.5, if you put it on a number line, so we have 1.5 here. So what is the greatest integer less than 1.5? That is 1, right? So then here the value of the function is 1. So if I take f of 1.8, right, again greatest integer less than 1.8. so if you take 1.8 here, still the integer less than 1.8 is 1, right? So this is your greatest integer function. Now what is the smallest integer function? So again the representation of both the functions is same. This is the smallest integer function. So here what is the smallest integer function? Smallest integer greater than the given value. Smallest integer greater than the given value. Don't be confused. Smallest integer function, smallest integer greater than the given value, right? So for example, if you put it on a number line, so we have 0 here, 1 and then 2, minus 1 and then minus 2, right? If I take f of 1.2, right, so that is smallest integer function 1.2. so we have this 1.2 here, right? So what is the integer greater than the given value? That is your 2 here, so which is equal to 2, right? So if you take f of 1.5, right, 1.5, so now here 1.5. now what is the greatest integer greater than 1.5? again it is 2. So if you take 1.8, again it is 2 here, right? So that is the basic difference between smallest integer function and then greatest integer function. Let me repeat again. Greatest integer function, integer, greatest integer less than the given value, smallest integer greater than the given value. So that is the basic difference, right? Fine. So now back to the question. The smallest integer function, okay, here this is 1 1 many 1 both. So if you take two sets A and B, so here the domain and codomain are not given. Let me take R and R, okay, both the function is defined from, because this greatest integer function is defined from real numbers to real numbers. So here the set A is filled with all the real numbers, again set B is also filled with all the real numbers. So if you take these examples, that is 1.2, which is a rational number, right, or a real number, what is the value of 1.2? 1.2 is connected to 2. If you take 1.5, again it is connected to 2, 1.8 still 2. So here all these three, 1.2, 1.5, 1.8, all three are related to 1, 2. So hence it is a many one function. Okay, fine. So first question here is the function f from a to b be defined by f of x is equal to 4x plus 7 and where x belongs to R. So we need to check whether this function is 1 1, many 1, odd and even. So we all know what are 1 1 and many 1, let me just give an example. Okay, 1 2 are related to AB. So this is your 1 1 function, and many one function if 1 2 are related to the same element, that is A. So this is your many one function and odd function. So if f of minus x is equal to, if f of minus x is equal to minus of f of x, right? So such functions are called odd functions. And what is even function? If f of minus x is equal to f of x, then such functions are called even functions, right? So now we need to check whether this function is which one of these. If you want, let me give an example for this odd function. So if I take f of x is equal to x cube, okay, so this is the given function, f of x is equal to x cube. So now here if I take f of minus x, we get minus x whole cube, which is equal to minus of x cube, right? So f of minus x is equal to minus of what is x cube, again f of x, right? So this is your odd function. And even function, f of x is equal to x square. So if I take f of minus x, so we will get minus x whole square. And what is minus x whole square? That is x square, right? So f of minus x, we got x square. And what is x square? We took x square as f of x, right? So here we got f of minus x is equal to f of x. So such functions are called even functions, right? So now here f of x is equal to 4x plus 7, right? So now if you want to check for 1 1, we need to prove that f of x1 is equal to f of x2. This implies x1 must be equal to x2, right? If this condition is satisfied, then such functions are called 1 1 functions. So now here, what is f of x1? You can take 4x1 plus 7. And what is f of x2? 4x2 plus 7, right? So if you simplify this, 7 and 7 will cancel. Then you will be left with 4x1 is equal to 4x2. Again 4 and 4 will cancel out. Then x1 is equal to x2, right? Hence the function is 1 1. And one more thing, so when a linear expression is given as a function or linear equation is given, so then it will be always a 1 1 function, right? So whether it is 4x plus 7 or f of x is equal to x plus 3 or f of x is equal to 3 minus 5x, all these are 1 1 functions, okay? Without a second thought, you can just write these function as 1 1. So what about many one function? If you have x square, okay, or if f of x is equal to x square or f of x is equal to 2x square or f of x is equal to 3x square plus 5, these all are many one functions, okay? Just keep this in mind. These all are many one. If it is quadratic, if it is linear, then it is 1, okay? Fine. So here 4x plus 7, definitely it is not many one function. And is it odd function or even function? For example, let me just erase it here. So here f of x, that is our 4x plus 7. If I take f of minus x, then we will get 4 of minus x plus 7, which is equal to minus 4x plus 7, right? So here, what was the condition for odd and even? For odd, it was f of minus x is equal to minus of f of x, and for even, it was f of x is equal to f of minus x is equal to f of x, right? So here we got f of minus x is equal to minus of 4x plus 7, right? So now here the function is, these two conditions are not satisfied by the function, because you can't write it as minus of f of x or f of x, right? Because our f of x is 4x plus 7 and here we got minus 4x plus 7. You can't write it as 0. If it is minus of 4x plus 7, then we could have write it as minus of f of x, then that could be your odd function. But here you can't express as minus of 4x plus 7 in this form, right? So it is neither odd nor even. Okay, the right answer is 1 1. Okay.